All right, everybody. Thank you very much for coming along again. This week is going to be looking at cloud computing, as I'm hopefully you're all aware already from my emails. I will let Carlos introduce himself. So that's all I've really got to say. So thank you very much.
Thank you very much. My name is Carlos Oliveira. I am the founder and managing director of Shaping Cloud. We're a cloud software development company. So we build software as a service, we build web-based solutions, mobile applications, and we do all of it using Windows Azure. So when I started the company, Windows Azure had just kind of launched, and the decision was made to just use Azure. We have zero physical infrastructure, we don't have a server, we don't run anything on premise. We run our company entirely in the cloud. Everything we use is cloud-based, everything we sell and develop is cloud-based. So today's really kind of a very brief look at what the cloud is, but more specifically about what you can do with Windows Azure and just how different it is to even 5 years ago in terms of what you can spin up, what you can create, what you can deploy in literally 30 minutes. So it's going to be a few slides just as an overview of Azure and the platform, and then a demo. So most of this is demo, actually spinning up machines, actually creating mobile services, SQL databases, all kinds of stuff, hopefully within 30 minutes, as long as the demo gods are with us. So the cloud is everywhere. I kind of regret now calling the company Shaping Cloud because it's been just completely hijacked by hosting companies who just do exactly what they did before, but now put a cloud badge on it. Broadly, it splits into three categories, and there's more, but the main three are these. So infrastructure as a service is kind of your hosting company end of the market, which is just, I've got a server sat here in my building. Rather than having it sat here in my building, I'm going to let someone else run it in their data center, and I'm going to rent it and pay for it on an hourly basis. So just replacing physical infrastructure as a service rather than having it provisioned on premise. Platform as a service, which is really what is of most interest to me as a software developer, and is really what Windows Azure, the heart of Windows Azure is about. It's broadened into all of these categories now, but platform as a service is me as an applications developer. I've built something locally. I've been working in Visual Studio. It's a web application. I want to now deploy this so that the world can see it. I can use platform as a service to just publish that directly to the cloud. Gives me an endpoint. I can set that up, and then everyone can suddenly connect to it. And then when I want to, I can scale it up to whatever I want. I can scale it down, I can turn it off, and again, you just pay for what you use. So from a software perspective, it just, in terms of previously, if I wanted to deploy an application, if I worked in a company or I was in any kind of organization, you'd have to go to the infrastructure team, you'd have to raise a request to get the machine provisioned, get that all signed off, then you'd get a machine, then you'd have to go and maybe put internet IIS on it, set everything up, deploy it. You're talking already days just to get that, and now it's minutes. Software as a service is probably the part of cloud that everyone is most familiar with. You just access it through a browser. So Facebook, Gmail, all of these things that are just accessing software through a browser. That's software as a service. So obviously Azure allows you to build software as a service. In terms of those three areas, it's kind of, each one has a different level of abstraction away from the physical box. So if you have on-premise, it's your machine, you own it, it's up to you to manage networking, storage, servers, middleware, data, applications, the whole lot, right? It's your box, your responsibility. Infrastructure as a service gets rid of some of that because all of the networking's handled for you, all the virtualization of the boxes themselves is done, but you're still dealing with a physical operating system, and it's up to you to manage it, it's up to you to patch it, it's up to you to keep it secure. Platform as a service is where you just focus on your applications and your data. So again, from a development perspective, that's brilliant because that's, my background is not in infrastructure. I don't want to be going onto boxes and setting up IIS and configuring all of this stuff. I just want to deploy my applications. And then software as a service is just completely 100% managed by someone else. You either pay for it on a monthly basis or it might even be free. So the cloud, like I said, is kind of everywhere, and it's sort of, everyone says it's the solution to everything, and it's not, but it is the solution to quite a lot of problems. And the four sort of key patterns where you should probably look at using a cloud solution is, well, first is when you just want it on and off, right? So you need a server to be available or a service to be available for a period of time, and then actually no one's going to be using it. You know, university, perfect example, out of term time, there's no need to have those boxes running, there's no need to be paying for the power, the electricity and everything else. Just deprovision it, stop paying for it, start it up again when students are back. So this kind of on and off, regular patterns, where you've got kind of, yeah, you just need it for that one period of time, turn it off again. That's a perfect sort of example. Growing fast, obviously, all startups today are based on the cloud. Everything in Silicon Valley is based on the cloud, because previously to get a company launched and going as an, you know, if anyone's seen, I'm sure most of you have, the social network, there's the whole bit where they're running out of money, they have to buy more servers to cope with demand, and they need $9,000 to get these servers and get them provisioned, otherwise, you know, the whole thing's going to crash. That just wouldn't happen today, because they'd be on the cloud, you know, and there's obviously other ones other than Windows Azure, and you just scale it. You add more services, you need it, you pay, and you grow as quickly as you need to. So, you know, in terms of barriers to entry, to getting something launched, to getting something in front of the world, you can deploy stuff for pennies a month, you know, a few pounds a month, and you can have an application that anyone could download to their mobile phone, anyone could go onto the website, whereas, you know, even on the cheapest hosting deals, you're talking for a decent hosting service, you know, a fair few pounds a month. Unpredictable bursting, so something where, you know, something might go viral, you might have a website or a marketing campaign, something kicks off on Twitter and suddenly you're getting flooded. Being able to scale that service is something, again, where the cloud is perfect. So you can hook into your application all kinds of auto-scale patterns, and Azure has like a button now that just says auto-scale this for me, and it will just handle it and say, you know, up to a certain limit, I'm going to just keep adding machines, keep adding endpoints to cope with the demand. As soon as it's detecting that demand's taking off a bit, bring it back down and reduce your costs. So, you know, it's a great cloud platform. If you think of that, before you'd had to have a physical infrastructure just to cope with that burst. Otherwise everything would fall over. And then predictable bursting. So good examples like a ticketing website. You know, tickets are going on sale on the Friday morning. You know it's going to be absolutely flooded for an hour or so. You can scale up your instances to really high levels to cope with that demand. As soon as the tickets are sold out, bring it back down again. And obviously, if you're coping with predictable bursts, it's easier because you can control it and you can manage it. Unpredictable bursting, you're looking at sort of auto-scaling. But those four patterns work really well with the cloud and applications deployed there. So Windows Azure, it's a set of services that let you build, host, and scale applications in Microsoft data centers. So, you know, it's open and flexible. It is not Microsoft only. You can build whatever you want on Azure. And I'll show you a few examples of the virtual machines you've got available. The mobile services that are on Azure run on Node.js. You know, this is not, you need to do .NET, you need to deploy .NET applications. It's a completely different world. Obviously, Microsoft have made sure that if you want to deploy .NET, it's very easy and it works very well, but it is totally open. And you can deploy to anything, you know, web-based software and mobile and tablet. So global footprint. So there's about, I think, 27 data centers now around the world. So these are all built, managed by Microsoft. When you're working on Azure here, most likely you'd use the North Europe data center, which is Dublin. And then there's West Europe, which is Amsterdam. And, you know, this is where Microsoft is clearly an American company because Dublin's further west than Amsterdam. And they're probably about the same in terms of north, but one's north and one's west, even though it's further east. But that's Microsoft. So the physical infrastructure behind that is immense. So Office 365, a load of the Xbox One cloud platform, all of that stuff is running on this same infrastructure. This is a massive, massive investment by Microsoft. And this is where it's frustrating when you see these hosting companies who've got a little data center down the road and they go, and we do cloud. Right, they don't do cloud. Cloud is this kind of global scale, a massive infrastructure that is available for you to use. So, for example, when you deploy anything to the North Europe data center, there's 3 copies of that living within the data center at all times. So there's 3 copies of your applications. You don't have to set this up, you don't pay for it, it's just part of the service that Microsoft provide. And the reason for that is, well, hard drives fail, networks go down, accept that, don't try and fix it, just allow it to fail gracefully and spin up a third copy. If the entire data center went down, the whole data center's disaster recovery backed up to Amsterdam. So by default, by deploying something to Azure, you've got a level of redundancy and security that you just don't have in even the biggest of organizations, that kind of setup. The data centers themselves are not your traditional data center, hot racks, cold racks, a guy walking around with a little monitor plugging it into computers and checking them. They're shipping containers, literally shipping containers, stacked 3 high with 2 cables, one for water, which is the cooling, and one for electricity. And they come packed full of servers. They plug them in, and there's a thing called the app fabric, which basically runs the data center and coordinates everything, and that starts syncing them up. At a certain point, when a certain number of hard drives are gone, or a certain amount of the hardware is just not working anymore, they unplug it, they ship it off to be repaired, they plug in a new one, right? It's like industrialized computing, which is why the costs are so much cheaper, and why, you're kind of just, it is an inevitable move towards this sort of computing model. Our office is in an old mill in Ancoats in Manchester. That building would have had a machine in it at one point, right? There'd have been a machine in there powering all of the machinery in that building. Today, you just plug it in. You don't care where it comes from. You don't need to have a team dedicated to maintaining it. You don't have to look after it. You don't get these big one-off expensive costs when you've got to buy a new machine. Instead, you just pay for it on a monthly basis, and you pay for what you use. And computing is going to be exactly the same way, right? You're just going to have the internet, that's your plug, that's your medium to access this stuff. If you're a travel company, if you're in whatever business you're in, why have you got dedicated IT infrastructure guys in your building maintaining these machines in a pit somewhere in the basement, right? It just doesn't make sense. So it's a big shift, and it is happening. So I'm going to talk a little bit about some of the different things that are available on Azure. And the basic one is virtual machines. So that is just, I need a Windows machine or a Linux machine, and I want to spin it up, and then I want to be able to connect to it and run stuff on it. Very simple, and again, that's sort of in that infrastructure as a service space. Websites. So, spinning up websites, creating websites, it's not difficult per se, but it can take a bit of time. Windows Azure, genuinely, you can have a website up and running in about 30 seconds, and it's free. So on any Windows Azure subscription, you get 10 free websites, and you get 1 free MySQL database. So WordPress, tons of stuff, pre-built galleries of different CMSs, e-commerce applications. Just pick it, click a button, and it will spin it up for you. It hooks into things like Git and GitHub, so you can automatically have your code, and if you're working on your code, every time you do a push, it will trigger Azure. Azure will get your code and deploy it for you. So again, being able to just focus on your application and focus on the development, not worrying about the infrastructure. That's what it's all about. Just focus on the code. Cloud services was how Azure first started, and this is very much platform as a service. So cloud services kind of take the concept of a web application and a virtual machine and sort of split it into 2 concepts of web roles and worker roles. So the idea being that your web role is obviously your endpoint. So you might have a application where millions of people are hitting a website, so you might have lots of web roles, but then they do some kind of processing which isn't time critical, can happen over a few hours, so that can all get loaded off to the worker role, and you might just have 1 or 2 worker roles working there. Or you can flip it round and have a very small web instance, but the things that people are doing on it are very complex, very real time. You could have a whole stack of worker roles. So it kind of forced you to think about scalability right at the start. And when you build cloud applications, you have to factor that in. You have to factor in things like state, and is this going to scale? If this is on 1 machine today and 10 machines tomorrow, will everything still work? And cloud services kind of helped you think about things that way. If I'm honest, they're probably now, with some of the new stuff on Azure, becoming less relevant because of the virtual machines and because of the websites. You can now achieve probably most things without cloud services, but they're still a valuable element. One thing we did for the University of Sheffield was a tool for calculating carbon emissions in the supply chain. And that's a perfect example of it's a website that might be used by 50 people. but they're running carbon calculation algorithms in the back end, which take quite a lot of compute power. And so we can have a very small web instance, and we've got a very powerful worker role that's doing the calculations and sending stuff back very quickly. Mobile services, this is kind of really cool. This is the new kind of stuff that came out probably about a year ago now. But in terms of rapid application development, this is fantastic. And I'll show you a demo of setting up a mobile service, setting up a database, setting up a REST API, talking to that REST API, and sending data back and forth. All very simple and very powerful. And when you're talking about just putting together, simple applications, proof of concepts, it's just fantastic. It's got full SDKs for all of the mobile platforms. So it's got push notifications built in. We're doing quite a bit around, so there's a tool called Adobe PhoneGap, which was based on a Cordova, which was like an open source project. And that allows you to take HTML and JavaScript, but wrap it as a native application. So you can deploy it to the iOS store as a native app. You can have all the native features of an app, like camera, access to your contacts, access to all of this other stuff, but the actual code is just pure HTML. So again, one code base, and you can deploy across all of these services. So Azure, as well as those sort of core features, has got a whole heap of other application building blocks. And it is a bit like Lego, right? Whatever you're trying to build, Azure's got all this stuff in there, and you might take, a couple of these, a bit of that, a bit of networking, and kind of pull together your application that way. It is just like a shopping list of stuff, and you take the stuff you need and use the stuff you need. And obviously you need to understand a little bit about the differences and the different ways they work, but when you see the demo, when you see how easy it is to set stuff up and how everything kind of follows the same pattern, you'll see me do very much the same thing 4 or 5 times, but achieving different things each time. So things like big data. So there's a service called HD Insight on Azure, which is all built around Hadoop. So it's Microsoft's sort of translation, if you like, of Hadoop for doing big data calculations. You've got databases on this, so SQL, but you can deploy MySQL, you can deploy Redis, you could deploy React, you could deploy whatever open source technologies you wanted. It's got storage, which is kind of, you're not talking about, when you talk about a cloud service, drives on a machine, because you don't have access to the drives. They've sort of abstracted that layer, and they give you storage, and it's very cheap and very fast. So for things like on a website, the images, the content, videos, that can all go into this sort of storage, into these blobs, and it's very quick to use. Traffic management, it handles everything for you. You don't need to worry about load balancing, you don't need to worry about any of this stuff. If you've got 10 web instances up there, Azure will handle the traffic for you and put it to where it needs to go. There's other stuff on there. Media services, if any of you do anything kind of around media and content encoding, the media services element allows you to have, upload your data, content encode in the cloud, and then have a streaming service set up. Again, built in, very quick. So SQL databases are obviously SQL Server in the cloud. It's clustered, it's fully managed, and you've got SQL reporting support. And SQL is one of those things, certainly when you go into businesses and you go into places, even in universities, getting a SQL Server set up and deployed is always painful. And you're dealing with DBAs who've got a million other things and aren't that bothered about your new test database that you want to get set up. So this, just having the ability to go click a button, get a SQL database, is a real time saver. So blob storage is that idea of having highly available and scalable file system. So it's not, it's not stored on a D drive on a server. It's stored in this blob storage, and it's just your data as a blob and metadata to describe it. So it's great for when you have any kind of content on a site, any kind of large files. You can put it into blob storage, and it's ridiculously cheap. It's geo-replicated across data centers, so it automatically will pull it down from the place closest to the user, so it's as quick as it can possibly be. Caching, all of the instances on Azure, like in cloud services and websites, have built-in cache. So the concept of, all of this drive towards virtualization, all of this drive towards the cloud is really about trying to make the most out of a processor, get the most out of it. How many virtual machines can we get on this? Because rather than having 10% usage, we want to get 90% usage. Get the most from your investment. And cache is kind of around that same idea. So you might have something, a service deployed, where you're at 50% usage of your CPU. You can dedicate, say, 40% of that to cache, in-memory cache available, and it will grow and shrink depending on usage. So, you know, if your usage goes down, it'll increase your cache size, and in theory, speeding up your site. So really clever stuff that, you know, just to build something, a good caching framework into an application, it takes time, and here it's just kind of made available. Identity. So you can create a website and you can hook into ADFS, so Active Directory Federation Services, which allows you to federate against a whole heap of web standards. So Facebook, log in with Facebook, log in with Twitter, you know, all the standard stuff that you see when you go onto a new sort of software as a service, it's just built in. So you create your application, create the ADFS, and then you can allow users to log in directly with Facebook rather than having registration pages. And obviously you can then also integrate directly with Active Directory. So if you're building an enterprise application for a large company who've got AD on-premise, it can hook in with that. And like I said, 93% of Fortune 1000 use AD. It's pretty much the standard in the industry. So just having that built in, again, it means you can build software as a service for enterprises, for the consumer market, for, you know, all different types of functions. Service bus is a service bus. It's messaging, very persistent, very fast, and allows you to build loosely coupled applications. So you might have a few things deployed into the cloud that kick off a trigger event that needs to do some processing on the back end. Just putting messages onto the service bus is a great way to scale out your application and keep the two loosely coupled. And again, when it comes to scalability, using things like service bus is a great way to achieve that, because you can have 3 or 4 applications completely independent of each other, but everything, all communication is handled by the service bus, and it's a really nice sort of pattern to use. A few others I spoke about. HD Insight, it's 100% Apache Hadoop. Media services and BizTalk services. I don't know if any of you even looked or heard of BizTalk. My advice would be don't, but if you want to, it is on there, but you'll be doing a lot of XML. So that was an overview of Azure as a platform. Now I want to actually demo it and show you what some of the stuff I've been talking about. So let's get my mouse. So just log on to the portal. So down the left, you can see all of the different things loading up, all of the different components of Azure that we briefly mentioned. So websites, virtual machines, mobile services, cloud services, SQL database, etc., etc., etc. And then on the right, you can see the actual things that are deployed and running in this cloud infrastructure. Now this, like I say, it's company portal, so you know, it's got all of our stuff. You know, everything that we run, all the things we host for clients and everyone else is on this portal. So if we start with the most basic and virtual machines, you'll see across, the really nice thing about this portal is the common interface and the way things are kind of made pretty simple to get going and set things up. So you've got this new button down the bottom here, you hit new, selected virtual machine, and I can pick from gallery. And these are a whole range of out-of-the-box images that Azure make available for you. So obviously at the top you've got Windows Server, as you'd expect. You've got other things like SharePoint. You've got full SQL Server, 2014 CTP2. So this is pre-launch stuff that you can go and spin up and play with, experiment with, learn on, you know, ahead of this stuff even being launched to the general public. So you've got all of the SQL Server 2014, SQL Server 2012, SQL Server 2028, BizTalk, Visual Studio machines. So these are these are great if you haven't got Visual Studio and you need a Visual Studio development environment. You can go on here, spin up a Visual Studio machine, which you can then RDP on, and it's got full Visual Studio to work and develop with. So if you haven't got a license or you're using the Express version, this allows you to get actually the full Ultimate 2013 version. Beyond Microsoft though, you've got Java, and then you've got, it was just announced a couple of weeks ago, all of the Oracle machines and platforms are available on here as well. And then you get into Linux, and you've got most other flavors of Linux that you can think of. But if one of these isn't for you and you've got a really bespoke Linux of your own, you can go onto My Images and you can create your own version, your own machine, and have that deployed to Azure. So, you know, you can basically run whatever you want on there. So if we start with Windows Server, say 2008, hit Next, give the machine a name, so Staff. Now you've got sizing, so right from extra small, where you're on a shared core with 768 meg of memory, right through to this A7, which has got 8 cores and 56 gig of memory. So what Azure allows you to do is either scale up or scale out. So you could either have a very large machine and just one of them, or you might want to have 4 small machines. It really depends on the application, really depends on the problem you're trying to solve. But you know, you've got full control over both. So you've got full control over the size of the machine, but also how many of them are running. So we'll just pick a small machine, set up a username and password. Hit Next, create a new cloud service, pick a subscription account that you're going to run it on. Here's where you pick your data center. So you've got North Europe, West Europe, and then the ones in the States and the ones in Asia. We'll pick Europe. Storage account, just use an automatic one. Availability sets are great if you're deploying a whole heap of things in Azure. An availability set says, I need all of these to live within the same app fabric instance. So it means that all of your machines will be close to each other, so they'll be even quicker. But that's only really needed if you're going to be deploying 3 or 4 or 5 things all into one kind of application. So here's where you can set up your endpoints. So if I was going to be running a web server on this machine, I can come hit HTTP. It's going to open up the port for me. You can pick the ports now. You can change these once it's set up and running. You don't have to do it all up front. But by default, obviously, remote desktop is turned on because you need to be able to get onto it, and PowerShell if you're going to be scripting. Hit tick, and that's it. That is now going and spinning away. So it's creating the virtual machine. So while it's creating that one, let's quickly set up another one with Linux. So let's go with CentOS. Don't want to use a certificate. You can, you know, it encourages you to use a certificate, but you can just specify a password. Next. Exactly the same kind of concept. Next. And we'll enable SSH, just so I can show SSH onto the machine. So that's great, and it's spinning up those virtual machines at the minute. Once they're up and running, obviously you start paying, and it's billed by the hour. I will show you the Azure in education. So Microsoft are on a big push in education in terms of Office 365 and Azure. And there is a promotional offer which allows faculty to basically sign up for what's called an Azure Pass, which is like a 6-month free access to Azure with a whole heap of included stuff. So I think 2 virtual machines, a load of websites, mobile services, all for free. So I'll come onto it a bit later, but for you guys to just play around with this stuff and learn it, you can go for that route. If you can't get your faculty to sign up for the Azure Pass, you can just sign up for a standard 3-month trial. So it's got a free 30-day trial that anyone can sign up for. You don't need a credit card. It will just, the minute you hit anything that is going to bill you, it will just stop the service and tell you that you need to put a credit card in to continue running these services. So no risk of getting a nasty bill at the end of it. So in a sort of maybe enterprise environment, you might want to set up a network and a virtual network. And you can do that from here. So again, new virtual network, and we'll do custom create. So a virtual network is obviously where we want to say, I've got my on-premise environment and I'm going to create these machines in the cloud, but I don't want to have to, manage them and manage these. I want to manage one network of machines. And that's what this allows you to do. It's just basically creating one network where you connect your on-premise to the cloud, and you can use them and monitor them just the same way from your standard server tools. I won't actually create one, but I'll just show you the process. So, that one taken. Next. So you set up any DNS servers that you've got in here, and then you can set up the VPN. So you can set up site to site, and you can set up point to site, depending on what your requirements are. Go through, set up the address space of your network and what is a valid address on your network. Name it, and then put a device IP for your router. So your on-premise router is where you put the IP address, and then if you hit next, there's just a few steps to follow on your router where you have to configure your router to allow, obviously, Azure to connect in and out and become part of your network. But it literally takes 2 minutes to do this. It takes a little bit longer to actually set up the router, but it's compared to normal networking, it's pretty straightforward. So he's still spinning. Which one's going to go first? So obviously, while this in the background is spinning up those 3 virtual machines in the North Europe data center. It's deploying an image, and that's normally what takes the most time. Really, is you've got however many gig of data and the image, which gets deployed onto the machine and then gets packaged, unloaded, and then provisioned. And so it's provisioning the endpoints, it's provisioning everything else in terms of connecting to it. Normally, still going. Move on. So the other part was around authentication. So Active Directory is where you can set up your authentication for your application. So you've got access control namespaces and you've got multi-factor auth providers. So this is a new feature and allows you to have a setup where, and then again, this is aimed really at the enterprise market, but obviously usernames and passwords, not necessarily the most secure. Multi-factor authentication will say you log in with your username and password, it will then send you a text message with a code, you have to put that code in to log on. So another layer of sort of security around any applications you're trying to deploy. Like I said, this probably got launched 2 weeks ago, and I can see it being a very kind of useful addition, especially for enterprises and clients who have maybe been a bit unsure about deploying stuff to the cloud in the past. So you can price it by user or by authentication, depending on your use case and your model. And here is where we've got an existing Active Directory set up, and you can see, obviously there's just me in there, but you'd have full usage of all of your users, and this is users who are on an on-premise Active Directory and in your cloud application, and you can control it. And the domains and applications that they can see. Is it going to create it?
Taking its time, isn't it?
Yeah. No, the Linux machines are normally quicker than the Windows ones. We'll see. Okay. So while that's running, I'm just going to kick off Visual Studio and show you cloud services. So another deployment way is obviously here, that's infrastructure as a service. We're just creating machines. But like I said, how Azure really started was around this and being developer-centric and developer-led. So in the new sort of Visual Studio, create a new project. You will need the Azure SDK. You can just download that off the Azure website. But it gives you the option here to create an Azure cloud service. So hit OK, default stuff. Now, this is where I was talking about the concept of web roles and worker roles. And this is where you would build up your solution. So you might have a web role, a worker role, and potentially work a role with a service bus, depending on what you were doing. And these are all sort of out-of-the-box applications built in, fully customizable, but it gives you the sort of building blocks for your application. So if we pick a web role and a worker role, hit OK, it's just going to create a standard ASP.NET MVC4 application. So we're going to say it's an internet application, which gives us some basic ASP.NET authentication out of the box. The engine you want to use for your views, rate is quite nice. Hit OK, and that's going to spin up. Aha. So coming back here, we've now got both of our virtual machines created. So if I click on my VMs, and we start with the Windows virtual machine. In my dashboard, I've now got monitoring of the machine. It will show me, what's happening on it. I can set up web endpoints, and this is where I can set up the auto scale. So if I want this virtual machine to be part of a wider network and I want the ability to auto scale it, I can set that up here. At the moment, I just want to connect to it. Button down the bottom, connect. Downloads a remote desktop file to my machine. Click it, connect. Put in the username and password that I picked before. And we're in. So that's a Windows Server 2008. Took a little bit longer than normal, but maybe 5 minutes to be spun up, available. That's my machine. I can put what I want on it. I can deploy what I want on it. Use it for testing. Use it for application development. And when I'm done with it, if I'm just done with it for now, because I've just spent a couple of hours, I can just stop the machine, stop the instance, stop paying for it. And when I want to start it up again, there's still my VM. It's still got everything on there. So it's literally just on and off when you need it. So great, again, for labs, for R&D, for test environments, just being able to set this stuff up so quickly. So while that's there, I'll go here. See that? Let me just come back a second. Waiting, maybe Windows open. Okay. If I go to my CentOS, so again, if I'm just on a Mac, well, I am on a Mac, but if I was just on a Mac, I can still use this portal. It gives me an endpoint here for SSH. So SSH. So the username, the default username is Azure user. Yes. Again, it's password. And now I'm on. So I'm on a CentOS machine. I've got everything I need on there. And you might have a GitHub project you want to deploy to it. You can just start running commands on it, get a web server set up, or whatever else you want it to do. Kind of open source. Really simple, really quick. So, come back over here. So that's VMs, very simple. Over here in Visual Studio, I've now got my default application. So by default, it creates views, MVC pattern, controllers, and models. Just a really basic starter website. So I'm going to run this. You see I have to run Visual Studio as an administrator. And what happens now is obviously normally that will kick off IIS or IIS Express, depending on what you have in your machine. Here it's kicking off the Windows Azure debugging environment, which is why you need the administrator provision. And that is down here. You can see you've got a compute emulator and a storage emulator. So it replicates how Azure runs in the cloud. So you can debug locally, work locally, and when you're ready to push it to the cloud, you know it's going to work. You know the way the compute works and the way the storage works is exactly the same. If I open up this, show compute emulator. I shouldn't have done that. Should wait for it to spin up. it's creating the roles. The worker role, I'll just show you the code for the worker role. Let it stop spinning. Is a very simple loop that just sits there, and every 10 seconds has a while true, and it will just loop every 10 seconds and print a message. So this is obviously where you might hook it up to a service bus, or just a simple use storage queues, where your web role, when something happens, you put something on the queue, and this will just loop and pick anything off the queue, do whatever it needs to do, and then send something back. Again, service bus is probably the nicest one to use and the quickest, but there's various ways you can do it. But really, it's just, you can think of it almost like a service that you would run on a machine. It's just waiting for something to do. What it does, what it waits for, it's entirely up to you. But by default, it just sits there and loops for 10 seconds. I need to load all of them. So this is out of the box MVC4 template set up. It's got a register page, it's got a login page, and you can just play around with it. It's just a starting point, but it does have quite a lot out of the box. And if I show you just that computer emulator that I tried to show before, so essentially on my machine it's created kind of another virtual machine. Bring that full screen. So this is the worker role, and it's running, and every 10 seconds it's printing working. And obviously you put whatever you wanted there in terms of the code. So obviously we're delighted with this application. It does everything we need it to do. So we want to push it to the cloud. We've done all of our development. It's ready to go. We want to show it to the world. I can click on the Windows Azure for Cloud Service, right click, hit publish. So it goes straight to Windows Azure. I pick my subscription. Again, Cloud Service, it will create one by default for me, create a new one for me. You pick the environment. Now this is obviously, if you're testing something, you've got by default staging and production. And the cool thing is, with Azure, you can have a staging environment where you've got your latest test version, and you've got your production, which is your live deployment. And on Azure, you can do what's called a VIP swap, so a virtual IP swap. What that means is you push to staging, you do any testing you want to do. Once you're happy with it, once you're happy for it to go live, go on Azure, click a button, test becomes production, production becomes test, and you're away. And obviously what that means is, in terms of rollback, if suddenly you're in production and you've noticed there's a bug or something you've missed, hit the VIP swap again, you're back to how you were. So really simple, nice, and easy way to deploy to staging and production environments. So we'll pick production and hit publish. So again, this is going to package up everything into what's called a CS package, create the cloud service, create the virtual machines for me, and it's going to create 2 virtual machines, one for my worker role, one for my web role. Deploy the 2 packages, set them up, spin up the endpoints, and everything else. I don't have to do anything, it's publishing, and we can just let that kind of run now in the background. Just replace. Oh, hold on, don't want to do that. I very nearly deployed that over a client site then, that would not have been good. Let's pick a different one. Let's create a new cloud service called Staff Cloud. Yeah, I could have just imagined my phone going in about 5 minutes.
But it'd all be fine, because you could have just swapped the stage.
I could have just swapped, although actually I picked production, so. Anyway, what could have been? That would have been an entertaining talk, watching me frantically try and cover that. Right, so that's going. That takes probably around 8 minutes, most. And most of that depends on your broadband in terms of just pushing the package up, because it's uploading that data. So I come back into here, and then you've got SQL. So I just wanted to show you creating SQL. Mouse, databases. Again, new, data, SQL database, quick create, give it a name, SQL, SDN, create. And again, this is something that previously you're waiting weeks just to get a simple SQL database, something that's going to work, and that's it, created. So if I open up SQL Management Studio, there's my database there, dashboard. It's got my connection string in here. Put that in. Okay. This was part of the demo, actually, I forgot. This is a good thing. It's stopped me from logging on because my IP address is not allowed. So by default, when you create a database in Azure, it will only allow other Azure services to connect to it. So in terms of hackers or people trying to get on your database or do stuff, you just can't. It's got an IP restriction. So if I come back into the portal, you'll see there's a little click here called Managed Allowed IP Addresses. And you see the only allowed services are Windows Azure services. And here it's picked up my current IP and very helpfully asked me to add that to the allowed IP addresses. Click there, hit save. Hopefully, I can connect. So in terms of security, it's just a really great feature because you don't tend to have to think about it. It forces you to think about it in terms of if you want access. So there's my database. It's there, SQL, I can do what I want. I can create tables, I can do everything you'd normally do on a SQL infrastructure, and that literally took a minute. So, the last part I wanted to show, no, not the last part, I'm getting ahead of myself. Penultimate part I wanted to show is websites. And again, you've seen it before. New website from gallery. And again, out of the box, there's a ton of apps on there. So different types of CMSs, blogging platforms, e-commerce, tools, wikis. You know, if you're working on a project or a collaborative project and you want a wiki, you can spin one up on here. WordPress sites are obviously great in terms of blogging and putting stuff out there. And it's just very simple. So if we pick blog, and we go with WordPress, pick your name, new database, should be this one. Next. So again, it's going to create a new database. I'll create it in the US just to, as you can. Hit go. Spinning up a virtual machine, setting up IIS on it, deploying WordPress to it, setting up a MySQL database, and it all happens pretty quickly. While that's spinning, I'll just show you the Azure and Education part that I was talking about before. So you have to go through an educator to get it, but they can basically, on your behalf or on behalf of the class, get these Windows Azure passes. So 2 small compute instances, 10 shared websites, 10 shared mobile services, 35 gig storage, 50 million storage transactions, so quite a lot, 250,000 service bus messages, and 750 hours of service bus. So it's a 12-month pass, and you can get 6 months for their students. So 6 months of Azure stuff for free. So if you are interested, just hassle whoever you need to hassle, because it's a really great offering. Cool. So that's it, the WordPress site's done. You can click on here, common theme, common application interface. It's there, I've got a URL, click on that, and I've got a WordPress site that I can go and set up, standard WordPress, ready to go. And it's free for the first 10. So, you know, again, virtual machines, cloud services, just in no time. So the last bit I want to show is mobile services. Now,
how's Visual Studio doing?
Huh?
How's Visual Studio doing?
Visual Studio still deploying. So yeah, it's giving me a URL. Looks like it's just deploying the machines. So it kicks it off, it deploys stuff onto it, and then runs it. Hopefully, should be good. So, new mobile service. Create. Give it a name. Free 20 meg database to get you going. Pick a subscription. Pick one that hasn't already got a free database. Has got a free database. They're all going to have free database. Okay, this one has. North Europe. Go. This is the database part of it. But this is about as much database information as you kind of need. So, mobile service, like I said before, is a REST API endpoint for your application. But it's built on Node.js, which means it is hugely scalable. So, traditional kind of web applications, a request comes in, it spins up a thread, that thread goes off and does something and comes back. Every time you do that, new threads take up a little bit of RAM. Average, say, 8 gig web server, you might be able to have 4,000 concurrent users hitting it before you're starting to run out of RAM and you need more memory and everything else. Node.js is entirely JavaScript on the server side, and it runs on a single thread. So it runs on a single loop, and it can handle about 1 million transactions concurrently on one thread. So in terms of scalability, it's just ridiculous. So all of the back end of this is built on Node.js, and when you code on it, most of the coding you're doing is Node.js. So this is a mobile service, and you've got kind of the main two parts, which are data and your API. And the two are kind of the same. Data has an API that is linked to your database. API is a completely custom API that you can write whatever you want. So data says we have no tables, so I'm going to add a table. Let's call it students. Obviously, you can set the permissions. Now, because it's a REST API, everything is done on HTTP verbs. So if it's an insert, if it's an update, if it's a delete, if it's a read, kind of same endpoint, it just uses a different verb to describe what it wants to do. So it's a really nice, neat API system. And you can control the permissions to do any of that. So you might have anybody can allow everyone to do everything. So that is creating a table in my database called students. So that's done. If I come back to my dashboard, you'll see I've got a mobile service URL, which I click, just says mobile service is up and running. So if I just take this portion here, staff mobile, and come into a little function called Postman, which is great, free Google app. You can just install it into Chrome. And if we come here, this is from a demo I did last week, but we just replace this BCS mobile portion with our endpoint, and it's going to tables. I do this every time. I change the name of the table and I have to do this. Anyway, students, send. Error unauthorized. Come back to here. Because I didn't set everyone. I said I'll set everyone, and then I didn't actually set everyone. So again, security is built in. You'd need an application key by default. Set it to everyone. Save. Okay. Now, should come back with nothing. Empty JSON string. Because there's no data. So let's put some data in it. So if I click on post, change that, and change students, So everything is JSON. You send JSON, you receive JSON. People know what JSON is. JavaScript object notation, right? So it's an object represented in JavaScript. So our object is me with a name and age. Let's add a course. Ooh. So course, computer science. Now, all that's changed from the previous one, where I did a get, is this verb here. So rather than a get, I'm doing a post, which is sending information.
Your quotation marks are wrong on the
Oh, yeah. Thank you. Send. Okay, so now I've got a response back very quickly with all the data I sent and an ID. So if I go to the back end here and go to browse my table, you'll see it's created a record in my SQL database. I haven't specified a schema. I haven't set anything up. I just sent it a JavaScript object. It's created the table for me based on that JavaScript object. So again, when you're talking about rapid application development, prototyping, getting stuff done really quickly, this is just brilliant. Now I can change that object. I can add new fields to it. I could add an extra column, and it will just handle it. It will null out the fields that don't have that column and just give me those new columns. That whole data model is dynamic. So I jump back into Postman and do a get. Here. That same get as before. I now get a record back. If we do another post, add another record. Tom. English. Send. Now I've got an ID. So it's handling all the IDs for me. And what those IDs mean is that I can then update using that ID. So if I come here and do that, and change subscribers to students. So it gave me the ID of 1. So the endpoint becomes student/1, which means just update my record. The HTTP verb's changed to patch, which is an update request. And I'm sending an updated name and I'm sending an updated age. I don't need to send course because that's not relevant. Hold on. Services, if we refresh this. So it's updated my name, it's updated my age. My course is still computer science because I didn't send anything in the patch request to change that. And you can see Tom's in there as well. So again, you've got the get. It's now got 2 records in there. Then the last sort of the basic CRUD operations, create, read, update, delete. Let's delete it. So I'm going to delete myself from the database. It has information in the payload, but it's irrelevant. The verb is delete. It's going against student 1. Send. Obviously an empty response because there's nothing there anymore. So if I come here, refresh, I've gone. So on each of those operations, you've got full control over them here in this script element. So you've got the insert, update, delete, and read, the 4 main keys. JavaScript functions, Node.js. I might want to run a function on update that sends an email. Azure hooks into a whole load of different applications, so like SendGrid, which is a cloud-based email distribution tool. So you can hook up to SendGrid and send out an email every time someone's updated a record saying record updated, etc., before it goes and executes the request. All of your custom logic can just live in this sort of API layer. If you wanted to do something that's not directly tied to a database, so it's not directly tied to an endpoint that is a table on the back end, so maybe you're pulling together 3 or 4 tables for a dashboard or for information, here's where you can create a custom API. And that is just, give it a name, which will be the API endpoint, and then the same in terms of permissions, and then it's up to you. You know, there's code that you can just stick in there and pull from whatever tables you want to and pull together the data that you want. It's got a scheduling service, so if you want to push out notifications on a regular basis, you can do that. Here's where you can hook up all of the push, so for Windows Phone, for iOS, and for Google. Obviously you need like developer accounts on different ones of these, but you put your certificates in, put your API key normally, you can then start sending push notifications. So, you know, if you have an app on a phone, people can do it. Identity is built in, so if you want people to sign in with their live IDs, with Facebook, with Twitter, with Google, you can use it. And again, configure and scale. So scale is in kind of every part of Azure. You've got this ability to scale up. We're on a free version, so it doesn't have the scaling built in, but I'll show you if we go back to Visual Studio. Okay, so that's deployed. Click there. My endpoint. And there's my application now running in the cloud. I can obviously change the DNS settings and have a nice URL on it, but you know, without me touching any infrastructure, without me even touching the Windows Azure portal, you can deploy an application and software to the cloud. If I jump into the portal, you'll see my cloud services. Am I going blind? Where is it? Let me refresh it. Here we go. This is the cloud service. So here's where you can have production and staging, and you can monitor both of them, and you can do the VIP swap down here. If you have one in each one, that's where you just hit the button to swap them. Obviously you can see it's monitoring it, and all of a sudden the CPU's gone from doing nothing to being deployed, and that's obviously us hitting it. And then scaling, you can scale them independently. So I've got my web role, my web front end, I've got my worker role, and you can scale these up to lots. So I might have 13 instances of that web role, which is obviously going to cope with a massive amount of traffic, but I could keep my back-end worker role just at one because it's not having to do a lot. And I can scale that, hit save, and I'm just going to start paying for it as and when I need, bring it back down when I'm done. So that was kind of a very quick run through of some of the things you can do in Azure. Like there's a whole heap of things on that left-hand side we didn't even touch. But hopefully it kind of gives you an idea of what you can do with Azure and with the cloud and with proper cloud, because that's proper cloud. Being able to do all of that stuff in 30 minutes or so, that's what the cloud should allow you to do. A guy down the road saying, I'll give you a virtual machine, pay me £20 a month, that's not cloud. So Azure scenarios, anything that's got to be scalable, that's got to be highly available, that needs to be fault tolerant is great. Websites, intensive apps, web APIs. You know, you might have an on-premise application that runs on Windows or runs on Mac and just uses the mobile service API to get the data. You know, you can mash up all kinds of hybrid scenarios of on-premise and cloud, depending on what you need it for. You know, things where you need burst capability. So once a month you might run a payroll, and all of a sudden that one server takes 10 hours to run your payroll. Burst it to the cloud, you could probably run it in 30 minutes. You know, scale up a load of instances and bring them back down when you're done. Social gaming, it's great for that. It's whatever you can do with a computer that you can think of is what you can do with Azure. So it's a pretty comprehensive set of services, and the key is they're sort of building blocks. You can pick and choose and mash them together and come up with something really big and really interesting. It is really down to your imagination and what you can think of. you know, it's huge. It's got a massive footprint. It's hugely available, 99.95. It's got virtual machines, websites, cloud services, and all that other stuff. The Windows Azure blog is obviously useful. Scott Guthrie in the States, he's like the guru of Azure. He's like the product manager for it. Any release of around Azure, any new feature, it always goes on his blog first, and it's a very, very good blog. Always quite detailed and shows you what's on there. We actually run the UK Windows Azure user group, which runs in Manchester and London. So if any of you are interested in attending or learning more about Azure, you can go on the website, see what events are coming up. The guys in London especially, they tend to run quite a few hackathons over a weekend, where you can come and do stuff around big data and things like that. So worth having a look at. And then really the actual Azure website itself is really good. Microsoft doesn't have a reputation for great documentation, but the Azure website and the documentation on it is just so good. So you come on here, you go to documentation, what are you interested in? All right, virtual machines, I just need to create a virtual machine. All the tutorials and guides are here. So this is Windows, and I've got creating one, logging on, creating images, managing the VM, great. But I want to use Linux, okay, here's a completely bespoke set of instructions for doing it on Linux or SQL or SharePoint. So, and that goes across the entire stack. So if you're looking at websites, again, if you're looking at doing it in .NET, Node.js, PHP, Python, it's all there. There's loads of videos, loads of hands-on labs, loads of walkthroughs. If you do get one of those Azure passes and you've got compute time, just running through them, it will really, you know, it's always easier to do it and see it, and it just opens your eyes to the possibilities of what you can do with it. So that was kind of it from a talk part, but if there are questions, just let me know.
I'm wondering whether you can customize the virtual machines, as in, for example, GPUs. Can you, like in Amazon, I know they have some instances where you can have like massive loads of GPUs through some proper number crunching. Is this available in Azure as well?
In Azure, you've just got the VMs that are in there. So
so the CPU and the amount of RAM dedicated to it.
Yeah, so I'll show you the calculator. So the Azure calculator is just all of the services on Azure, and where you can go and see pricing. Obviously this is the commercial pricing, this is what the big corporations pay, but not necessarily what you would pay. Here's the full calculator. Let's change it back to dollars. So virtual machines, you've got from so extra small instance, one Windows virtual machine if you just wanted a really simple, and this is for running 24/7, would cost you £10 a month. So 13 pence, 1.3p per hour. Small, start to be a bit more significant, but then, you know, on a small virtual machine, you're on dedicated cores, all the way up to A7, you're talking about quite a lot of money. But again, the per hour price is nothing. £1.30 to have a very powerful virtual machine running for an hour. So
you can bring it down.
Exactly. You just
okay.
On any of these services, on any of these virtual machines, let's go to the Windows machine that I said before. So right now that's running. It obviously hasn't been up for an hour yet. So from here, I can just hit shut down, and that's it. I stop paying. So I'll have been billed for 1 hour of that machine, and as and when I want to bring it back up, I just spin it up again. So that's the thing. Azure, you shouldn't think of things as, you know, the price here is 24/7 running all the time. You shouldn't have stuff running 24/7 in Azure. I mean, you know, for a lot of scenarios where it's really good, that burst capability, that on-off, you want to be thinking about how can I minimize it. So often with clients, if it's internal software, we just schedule it to turn off after 7 PM, spin back up at like 6 a.m. so that, because people only use it during office hours. So for them, it massively reduces their costs. It just depends on, how you want to use it. Again, everything's on here: SQL Server, BizTalk, the web and worker roles, the mobile services. You can kind of work out the costs on anything. But as students, a lot of this stuff you can get for free. Anything else? Yes?
You nearly had an accident on one of your client software.
Yeah.
What kind of working practices do you have to put in place to avoid that kind of disaster?
So, in our normal deployment procedures, I wouldn't be going into the portal and deploying from there. So we have everything set up on in Azure. We have an instance of TeamCity, which is a continuous integration server. So TeamCity sits there. Anytime anyone in the development team pushes the code, it goes to TeamCity. TeamCity runs a load of integration tests, runs all of the unit tests, and basically passes or fails the build. So if the build fails, all the developers get an alert saying whoever's just pushed that latest change has broken the build. Developers then go and kind of work out what's happened and fix it. Once the build's stable, at the end of every day, the last working build automatically gets deployed to a staging environment. And that is then available to the client for testing. So clients would be able to go, or if it was an internal piece of software, we would test it and run any UAT that we want. And then when we want to go live, we use that VIP swap. But we have it, everything that you can do in the portal, you can do via PowerShell and scripting. So we have a whole load of stuff that is scripted through PowerShell. So we do the VIP swap, but we do it in a scripted way. So yeah, that would be a normal development kind of test, UAT, production cycle. And it all runs on Azure. Anything else?
Are you in control of the cloud? Are the applications, you show that they are secured originally, but can you go into even more, such as encrypt the hard drives? Because some of the companies are very, very fussed about storing their pupils' records in the cloud, but not being in control really of the...
It's the big thing. It's the first thing most people ask about the cloud: is it secure? And most of the time, what we say is, well, how secure is it sat in your data center here? It's got a cable. It's plugged into the internet. It's just as vulnerable as anything sat in a Microsoft data center. The difference with a Microsoft data center is you've got a team of engineers who are 24/7 monitoring it and making sure stuff doesn't happen. And equally, the infrastructure behind it means that in terms of disaster recovery and failover, it's normally way better than most people's on-premise. Often companies, the IT manager who's managing their infrastructure is doing about 10 other things. And how much is he patching those machines? How up to date are they? In terms of encrypting hard drives, if you have a virtual machine, it's yours. So yeah, you can do all of that.
Patching cycles as well.
Not on infrastructure as a service, only on major stuff. The idea is really that it's your machine. On platform as a service, on the cloud, where we just deployed an application straight from Visual Studio, on the mobile services, all of the stuff where the infrastructure's abstracted away, that all gets managed by Microsoft. So yeah, we're on the G Cloud framework, so in terms of being able to supply to government, and Azure is IL2 Cabinet Office certified. So Cabinet Office kind of got Impact Level 1, Impact Level 2, Impact Level 3. Impact Level 3 is, like highly confidential, can't really get out to anyone sort of data, and that is still not sort of cloud, or Azure doesn't have that accreditation, but IL2 is pretty high, pretty hard to get, and it is certified for IL2 applications. So yeah, it's just something that over time people's perceptions will change and they'll realise, and it is a secure platform.
As a student studying computer security, I have to admit that I'm really interested in the VPN possibility, because if someone somehow managed to get one of the machines, will actually manage to, if it is enabled, could potentially actually go all the way inside your own network, which is very interesting as a possibility, vulnerability, let's say. Yeah,
but in terms of the connection, it all comes through your router. It's all based on the IP addresses. And it's a tunnel, right? It's a direct tunnel. if you go down the infrastructure as a service route, all of the normal principles of IT security apply, right? There's only so much they can do. The platform as a service, websites, mobile services, that's kind of just managed for you. But if you're interested in infrastructure as a service, then yeah, you still have to control it. It's that slide right at the start kind of thing of, you know, you're still running all of that stuff and making sure your operating system is secure and everything else.
You mentioned sort of halfway through about Xbox One and its sort of GPU rendering capabilities.
Yes.
Do you know if there'll be any sort of announcements or things, or have there been any announcements about making that more publicly available in terms of?
I don't. We're not big on gaming. I know we're part of an Azure insider list, which is it's like an email group, and I've seen stuff going backwards and forwards about Xbox and some of the stuff on the Xbox One. I'm sure there will be announcements. I don't even know if Microsoft formally have said that it runs on Azure, and obviously lots of people in the Azure community are say that it runs on Azure, but I think from a Microsoft perspective they're kind of hedging their bets a bit, because if there are issues with Xbox One, like Grand Theft Auto had issues, didn't it, with the cloud platform, I guess they don't want to then that to impact negatively on Azure sort of thing. So I'm 90% sure it is on Azure, but I don't think there's been official confirmation on it. They're actually building another data center at the moment in Finland, which I think is all down to the sort of Nokia acquisition, and so there's definitely going to be some interesting stuff around that as well in terms of devices and services, because that's Microsoft's big thing right there. It took them a very long time to get onto this and onto the cloud stuff, but when we started the company, certainly 3 years ago, it was just Amazon, right? That was the only conversation you had was Amazon. And Azure, it's just developed so much that in most aspects it's past Amazon. The recent Gartner survey kind of put Azure now as the leader in terms of functionality and offerings and completeness of vision for the cloud. So yeah, I just think they've got it now, Microsoft. The Office 365 stuff, the Azure stuff, the Xbox, even the Windows phones, they are getting better. So yeah.
How fast do Microsoft iterate on Azure then in terms of new features?
They tend to do, there's normally a kind of new features a good way to do it is just go to Scott Boo's blog. Every couple of months, and then a major launch probably twice a year. So, this is all the announcements. They always come on his blog first, so you can kind of see there's, pretty regular announcements. It's annoying it doesn't actually show you the dates, but it is very regular. And like I said, his blogs are just great, because if there's an announcement about Azure, it tells you what it is, and then he demos it and shows you what you can do with it. So, really worth looking at. That was Friday.
Shaping the Cloud, it is on Azure, right? Like the website.
Yes, yeah, our website's on.
For a year, how much do you pay roughly for that instance, I guess?
Yeah. For our website, it's free because it's on the Azure websites. So,
okay.
So we have a free MySQL, it's a WordPress site, and there's no cost. We also have, as Microsoft partners, we have MSDN subscriptions, and with MSDN subscriptions you get a load of Azure time as well. So,
also there are certain plans.
But if for whatever reason you were not on the free tier, I've gone past it. Website's shared on site. So $10 a month. So £6 a month for a hosted website. So it's cheap. When you go into commercial discussions and you go into what physical infrastructure costs and you go into what you could save, you're talking hundreds of thousands of pounds for a fairly medium-sized company that they could save. We do a lot with education and schools. There's a school in North London who are looking to move their infrastructure to Azure. They currently pay RM, I think £120,000 a year for 9 servers, which is just bonkers. So they could save, I think we worked out, it might cost them around £20,000 a year on Azure to have all 9. But actually, if they move to Office 365 and got rid of their email server and they move other things to different cloud services, it comes down to about £10,000 a year. So, you know.
Overall, wow. That's good.
It's,
That's a really cost saving.
it's not bad.
Do you by any chance know the name?
Sorry?
Do you not by any chance know the name of that school?
I do, yeah. I can't really say. Because we haven't won the contract yet, so.
I was wondering if you could do some crystal ball gazing for us. So you said that companies are going to be less likely to have their own servers and their own IT manager in the basement.
Yeah.
And presumably those jobs are going to be in Microsoft instead and similar companies maintaining sites like this. So what kind of skills do you think that students should be developing in order to go through these things?
I think I'm slightly biased, but yeah, software and development is the infrastructure is commoditized. Think of it, but it's like working in a power station. Yeah, there's going to be absolutely specific skills to go and manage these, but a Windows Azure data center in terms of physical staff, I think there's about 8 in a Dublin data center, because they're just boxes, right? They're mainly, most of the staff are security, physical security. Everything else is done by people in Redmond and people in the States. So the software development aspect is what companies need. Software as a service, building web applications, building applications that can use the cloud intelligently. Big data is a big buzzword at the minute, and there's definitely huge potential in that as careers go. Where I actually met Paul was at a talk at UCL, and Rob Fraser, who's kind of the UK sort of product head for Azure, spoke a lot about data scientist being the next kind of role. So yeah, things like being able to code Python and dynamic languages, real-time data and being able to code against real-time data sets and business intelligence. In the enterprise world, in big companies, that's what they're looking for. We got asked on the G Cloud to do something for the NHS around big data, which was consolidating 28 data sources and putting big data stuff. And it's not something we get heavily involved in, but the other guys who run the user group with us, that's their thing, that's their company. So we spoke to them, and they quoted us about £1 million to do this on a day rate of £1,200, which was them, cutting it, giving us, a good price. So yeah, that area at the minute, companies are paying a lot of money if you can, understand big data. And the actual thing is, there's not a lot to understand about big data. It's more having the patience to deal with it, because it's just fiddly and complex, but it's not really, from a code perspective, that difficult. But yeah, just companies and the way we use IT is, Google have got the Chromebook, no operating system, everything in the cloud, and every iteration of that you can see the reviews of going, actually this is becoming more feasible. Whereas at the start people are, that's just crazy, I have to have this piece of software installed on my machine. But that is just, disappearing, so abstracted away.
How big a site can you actually build on the free servers?
On the free servers? How
many pages or how many?
It's just the limit's just the database, really. So trying to think of the size of the free database. I think the free MySQL is 20 meg, so it's small, but that's still quite a lot of pages and content if you're just talking about a basic site and a basic blog. And obviously you don't store any images in that database, store them elsewhere. You can get, as a bit of commercial website, then it's totally feasible to have it on the free instance. The thing is as well with Azure and the websites is, I showed deploying a WordPress out of the gallery, but you could deploy from Visual Studio this MVC web role as a website. If you don't need the cloud service, if you don't need the worker role, you don't need any of that, you just want a web, then from Visual Studio I can deploy that as a website directly as well, and have a SQL database on the background.
Cool. It's my turn. Well, thank you very much for being nice and quiet. I will hopefully see most of you next week, where we're going to be looking at SCADA security and SCADA systems in general. It's very good for software engineers, people who are interested in sort of large-scale systems. So this guy works for EDF Energy, and he works sort of in the power stations and actually building the systems that the power stations use to actually make sure they don't all blow up. All right, and make sure no one can hack into them and things like that. So that's what we're focused on. So very good for anyone in that field of interest. All right, so thank you, Carlos. Thank you. And if you've got any individual questions, we'll mill around at the bottom for a little bit longer.